All right, let this be a lesson to not change your stream settings or update the program right before the stream because it deleted all my settings. But here we are, alas, streaming again. And so just as a quick note, I changed my camera position because I don't want you to see my whiteboard. There's too much EmberGen stuff back there. And then the second thing is on June 21st, we're having a live stream where we will show EmberGen live. We'll show GeoGen. We'll show, EmberGen updates and things like that. So pretty cool. So that's going to be on June 21st. So go ahead and go to our YouTube channel or whatever and find the live stuff that's upcoming and hit the notification bell for that. It's going to be a really big stream. Yeah, so pretty interesting. You can see my EmberGen shirt here to tease all y'all while we do mastering particles. So without further ado, thank you all for joining the stream, and hopefully the sound is good. Give me a thumbs up in there if the audio is fine, or if it's too loud or something, but because I had to reset all my settings, unfortunately. Regardless, this is going to be a really educational stream. We're going to be going over pretty much everything you need to know about GPU particles for EmberGen. And by the end of this, you should be really comfortable creating particle systems, exporting them, creating awesome explosions with them, influencing, various simulations and learning how, all the dynamics and things like that work. So it's going to be really cool, and hopefully it won't run too long, but this is a live training session. I've tried to plan some things, but as always, what can go wrong will go wrong. So pretty cool. So by the end of this, you should be near an expert on how the particle systems work. They're really complicated, but at the same time really simple if you can learn just a few key concepts. So other than that, let's go ahead and hop into our presentation here. And let me just go ahead and turn off my camera. Oh my gosh, look, it's EmberGen. I'm here to tease you even more. Look at it running in real time. Whoops, goodbye. And so, other than that, let's see. So, live training number 6, mastering particles. We've got what is a particle system. So, to begin, a particle system is a group of points in space guided by a collection of attributes that define their behavior and appearance. So, more or less, imagine a bunch of points floating around and things like that, and you can tell them what you want them to do. A single particle is just a point in space. Looks like I got a typo. Guided by a collection of attributes that define its behavior and appearance. So you can have a single particle, and then a particle system is a bunch of particles or points in space, and they are typically in sprite form, so they're facing the camera or whatever, and it's pretty interesting. So what attributes do particles have in EmberGen, or what is an attribute? So basically, they have an emission attribute that determines how the particles spawn or when they spawn. You can determine whether or not the particles spawn frozen or not. So they have a freeze attribute, which basically says, hey, I'm not going to move or do anything until something happens to me, whether, say, a force happens or a certain amount of time passes or whatever. And that's how you can dissolve objects and things like that, and we'll go over that soon. You've also got the lifetime. So how long as a particle am I going to live? Am I going to live 0.1 seconds or 3 seconds or 10 seconds or whatever? We've got initial forces. So what force is going to be applied to me whenever I spawn? Then we have active forces, which is forces that influence the particle's motion during its life. So as I am iterating through the simulation, every single frame, what outside forces are going to influence how I'm acting? Because I had an initial force on me, probably, but is anything else going to happen to me each frame that the simulation ticks? So that's what an active force is. And then we have collisions. So it could be an external collision force that's caused by colliders in the scene, or say the bounds or whatever. But one note is that particles cannot collide with each other at this time. So if you're trying to get like a granular simulation or something like that, and you want all the particles, to pile on top of each other, it's not going to happen. They're just 2D sprites right this second in EmberGen. And then with shape, that basically determines the size and the shape of the particles. So either they can be circles, which is your typical sprite, or they can be elongated to look, kind of like a line. And so it's just the circle turned into an ellipse, and it orients towards the velocity of the direction the particle's traveling. So those are the two shape types. And then we have rendering, so basically determines the render mode. So do you want it to be translucent? Do you want it to be lit? Do you want them to be additive? Do you want them to be emissive, etc.? And then you can also choose like your color and do some cool modulation, like color over, velocity, color over life, color, through whatever. And then finally, there's injection, which is probably the best attribute for particles in general, and it's the most useful thing. So you can add data directly to the volumetric fluid simulation, and we'll go over the difference between the volumetric fluid simulation and the particles here in just a second. So what's the difference between a voxel and a particle? A lot of people get confused about this, on like support requests and all this stuff. They say, my particles aren't doing whatever. EmberGen's explosions, fire, smoke, etc., are composed of a bunch of little cubes arranged in a regularly spaced three-dimensional grid. So a particle is a single point in space. You can see all these little singular points, and then they make up this blue cloud from this dissolving portal that's a preset included inside of EmberGen. And then voxels are lots of millions of little tiny cubes, and we make them glow or have density for smoke or whatever it happens to be, and activate those different voxels whenever there's data in them. And it gives us, with enough resolution, some really nice, fire, smoke, or explosions or whatever. The cool thing about this explosion is it's driven by particle systems as the emitter, and then it injects fuel and all that stuff, and we'll go over that soon. But yeah, so a particle is a singular point in space. A voxel represents a single cube in a regularly spaced three-dimensional grid. And so voxels are volumetric, particles are just sprites. Why do you want to use particles? Well, particles are useful in two main instances. You want to render millions of points in space, just like this, for a different look or whatever. These work really well with stylization in EmberGen too. So maybe that's what you want to do for sparks, ash or magic or whatever it happens to be. They work really useful for that. Or you want to influence a volumetric simulation in a more realistic way. So you want particles to inject a lot of velocity inside of a simulation or something like that. So lots of really cool stuff you can do. And then one of the last slides here is forces in particles. So there's two types of forces, and this is probably one of the most important things to know about the particle system. And so basically you have active forces, which could be, force nodes influencing particles. It could be gravity influencing particles, dampening of the velocity influencing the particles. And then you have a volume slider, which basically says, hey, I'm either going to take in velocity from all of my, force nodes, gravity, dampening, or I'm going to do either 50%, 100%, whatever of the volume. And if you have 100% volume force, the particles will follow the volume specifically. It's kind of hard to say, and you'll just have to see it to believe it or whatever. And so I'll show you in EmberGen here in a bit. And then initial is just, the localized force on spawn. It only happens at the instant the particles spawn. But yeah, so we'll go over these forces, but they're really important. And this particular thing, the volume slider, is probably the most important thing that you can learn today with the particles. And then finally, export. So you can export them as an image from the render node, or you can export them as an alembic file from the export particles. And you have to drag off the particles pin from the sim, and then it'll just spawn, and there you go. So easy to do alembic. So that's how you export. And so we can go ahead and get rid of our presentation there. And here we go. So more or less, this is EmberGen. And just give me a quick second. I need to download a couple of presets just real quick. I tried to do it beforehand, but got really busy. So let's see. 1 second here. I got to go to my stream thing. I'll just let this play to keep you entertained for a second. Okay. Save, and then finally save. And so let's see here. Okay, so finally ready here. All right, and let's just make sure that I go to the thing. My apologies for the delay here. I have way too many folders on my computer. Builds, live stream. Okay, finally, we are ready. So, we're set. So the first thing we're going to go over is kind of, the difference between forces. I think that's really important to go over at the beginning here. So more or less, before we get into how to spawn particles or how, to freeze them or their lifetime or whatever it happens to be, you can see that we've got two different emitters. So we've got a spherical emitter here going to an emitter volume, which is the voxel-based emitter. And then we have the emitter particles, which is spawning all these little points in space. And so we can see if we restart the sim, these particles are lit. They're being shadowed by a point light. And then we've got the smoke here. And then whenever they interact, you can see that the particles are going to get pulled in. We can press M to hide our simulation. And you can see the particles going with the flow of that simulation. And so if I come over here and say drag this right in the path of that smoke, you can see that they are fully interacting with where the smoke is. So for instance, if we did want to basically turn the smoke into particles, more or less you could just plug the same shape in and it's going to do that for you. So that's one way to, basically turn from a voxel simulation to a particle simulation, more or less. It's not as easy as it used to be in the old EmberGen, where it was more of a direct correlation to where voxels were. But in this case, it's pretty close. So with that, showing off the active forces slider here, you can see that right now volume contribution is set to 100%. If I drag the first bar here for our min-max slider all the way to 0, you'll see that some particles fall straight down, and then there's a gap kind of in between where some of it is being influenced by the volumetric simulation, and then the rest is fully simulated. And then if we drag this all the way down, you can kind of see the particles changing, and now it's only influenced by the active forces. So in this case, gravity intensity, some velocity dampening, etc. We've got like a gravity multiplier, so we can say, hey, I want you to accept, kind of all of gravity or none of gravity, and kind of go in between. And then it's the same thing with the volume. So we could say, hey, I want to do, only 50% and 50%. So I'm going to be affected by my gravity quite a bit, and I'm going to be affected by the volume simulation. And so this is a good medium if you want, some cool turbulent motion in your particles, but you still want it to be affected by other things like gravity or a force noise or whatever it happens to be. Now, one thing to note is that if you have a force noise, and in this case it's affecting both the volume and the particles, you can have a force noise that only affects the volume. And in that case, so say for instance, if we came here and we drug off and we did say a line force and we wanted a twist strength, and then we said only volume, and then we make our volume slider 100%, you can see that the particles are indeed going to follow this line force. And let's do something like 20 or whatever. And so you can see that the line force is pushing these particles around. And and we can make it, say, do like a negative repel or something to really kind of bring this in. And so kind of interesting. And if we show our simulation, this is what's happening. So I'm not sure why it's not rotating around, since this is a twist strength. Hopefully something didn't break. 50? Yeah, I don't know. I don't know if that's a bug with the build that I have or what's going on, because this is a new build. But either way, we've got a thing here happening. Let me just turn on my visual for the gizmo arrow size. Yeah, this doesn't seem correct. I think this force is broken or something. Dun dun dun! Told you something would go wrong on stream. And so, but either way, so forces that are affecting only the volume would affect the particles too, since they're fully affected by the volume. And then we have it so that if, say, we chose only particles, and then let's go in and say add a force, and then do force noise, and then let's choose, say, particles only, and then we choose our amplitude. We can do, say, 50, and oh, let's see. Maybe it was because I only had it in the emitter. I think that's what was wrong. Maybe I accidentally plugged it into the emitter instead of the simulation. So that was probably my mistake instead. And so now you can see with the force noise, the particles are being affected by it, and so they're going really crazy. But if I go back and slide this slider to full volume, that force should not affect the particles at all. So we can see that that is true. So really quite interesting. And hopefully YouTube doesn't compress this stuff too bad with all the particles flying around. It's probably bad for YouTube compression, but we'll see how they do. And so other than that, we can go ahead and start a new project file just real quick, and we'll probably come back to this preset here soon. And we'll just go over kind of how particles work. And actually, let me show a few examples of particles, just so you kind of know what you'll be able to learn today. So in this case, we've got a bridge collapsing from frozen particles. You can see it's injecting a lot of smoke. And then, say, in this case, this is also frozen particles. And it looks like these particles are kind of dissolving this portal or whatever, and so you can export this as a Leanback or whatever and render it in another tool. Looks really great inside of EmberGen 2. So you can see that they kind of rotate around, they get sucked in, and all kind of stuff, and that's through various forces that are being animated on the timeline. And this is a preset that's included with EmberGen, so nothing particularly new. And then you can also do things like smoke shockwave. So we have a particle system that's kind of got a cool initial velocity going on. If we go to active forces, you can see that it's kind of in between. We've got a lot of them following their own active forces, and then we've got about quite a bit following the actual fluid simulation too. That gives us a nice variation where if we did say all of them following, there's a lot more particles that just expand outwards, where if you add some that are following the volume, it kind of gives us a bit more of a wider smoke plume, since some of them kind of get delayed and they have drag and things like that. So pretty interesting. So yeah, so let's go ahead and start our new project. And so we'll just do don't save. We'll just do a default one here, and you'll see that by default we can choose either an emitter or emitter volume or particles. And you can see that it go ahead and tries its best to recreate the fire that we had from the volume. The volume is a bit different because it has maybe a smoother emission. It's coming from a signed distance field shape, and you can change the radius of that or whatever. And in this case, we also have something called an emission gradient. So if the emission gradient is low, it's a pretty hard shaped emitter, but you can do a gradient here, and it adds in some pretty neat noise and things like that to smooth out the emission. But in this case, we're focused on particles. And so by default, you can see that we have an emission rate of about 125,000 particles. We could choose, in this case, we have continuous emission. but we also have a burst emission. So if we turn off continuous and we just have burst, then this is how you kind of make an explosion of particles. And in this case, the burst size looks to be about 1 million particles, and so it's just quickly bursting, and that's it. You also have an emission parameter called jitter distance, which basically says how many meters from the shape that I'm spawning in am I going to emit from. So it's kind of like the emission gradient, and kind of gives us a bigger emission. It's particularly noticeable on, say, something like entangled. So say if I go here to continuous emission, and then we do, let's just say a few particles, so like 2,000, you can see that there's this line traveling around our torus, and that's just the entanglement emitter, just kind of picking random points and then drawing particles between it. And if we increase our jitter distance, you can see that it's kind of localized to the jitter, so it kind of makes our jitter, instead of a line, more of a cylinder. And if we increase our particles, you can kind of see what that's doing there. So kind of interesting. You also have a randomized seed. So for instance, if you had, say, you wanted to randomize an explosion or something like that, it has a dice icon here, and that's something new, and it kind of coincides with the dice icon up here. Or if you've updated EmberGen, we have a whole new randomize all thing. So for instance, just real quick, I could come in and say, hey, let's take maybe my major radius, and we want to do, actually I have to shift click. We want to add this to our randomized parameters, and we can see it here. And then I'm going to say, hey, I want to randomize between, say, 4 and 2. And so now whenever I randomize all, it's going to give me a randomized torus radius. And so this is a great way to create different variations. So, randomized gravity or randomized buoyancy, randomized emission rates, whatever it happens to be. And quite interesting. So this is more in depth than I can go into today, but that's just to let you know what this new dice icon means. Of course, since this is kind of the master class, we're going to go over a little bit of everything. So position, of course, is the position of your particle emitter. It is separate from the position of your shape. So if you want them to be kind of coincided, or whatever, you want to change the position of your shape. But if you do want to change the position of your emitter, you can do that. You can also rotate your emitter. We just went over burst size. We also have spawn on surface. So maybe you only want to spawn on the surface of your object, so you can do that if you want to. We can turn off our jitter distance. And then finally, also in emission style, we have clumped. Basically what that means is we're going to spawn a bunch of little clumps of particles. And so basically once the emission counts reaches whatever the clump count is, so once we've emitted 5,000 particles, we will spawn them. So for instance, if we have, say something like 3,000, it's going to burn in that clump until it reaches a total of 5,000 being spawned in that clump. So that's kind of how this works in its randomized positions. Now, the clumps are actually spheres. So if we go over here and we create a box, and the box is even, we'll see that the spheres are perfectly spherical. But if we say induced something on one axis, you can see that now the spheres are going to be stretched. And some of them are trying to spawn outside of the bounds, because particles can spawn outside of the bounds. And so for instance, if we go here and we've got our particles line connected, on a lot of presets I think it's disconnected by default, but if you don't see your particles, you can connect the line. We're going to go to rendering and we'll say render particles, and then we can probably go to shape and really increase the size. And so now if particles spawn outside of the bounds, we can see here they're spawning outward, but because they're not in the bounds, it's not going to create fire or whatever. So having boundless particles is a really important thing that we will go over in the future here in just a bit. But back to emission, we're almost done with this tab. You do have a clump size, and so let's go ahead and bring this back into the bounds. So you do have a clump size where you can choose how big the clumps are, and so this is really cool for, say, a bursting explosion or whatever it happens to be. Really quite awesome to get something explosive by having a large clump size. You can reduce the amount of particles per clump if you want to, or you can have it, only be a ton of particles per clump. And so you can see here, it creates a really interesting emitter shape on the very first frame. You can kind of skip through, and you can see how it spawns this explosion with a bunch of random little balls. You can also reduce your particle count or whatever, so pretty interesting. And then finally, we have emission conditions. So if we say velocity higher than whatever, it's not going to do anything because we don't have a high enough velocity. And so I believe we actually have to, it's funny because this is for both particles and this. So I don't really know how the velocity thing works. So not much of a masterclass, huh? But I do know that for sure that velocity lower works. And so basically if the velocity is lower than 1.2, those particles respond. I typically don't use velocity as an emission style. What I'll typically use is, say, inside of a masking shape. So for instance, we have our main shape that we have here, and then we've got our masking shape, and then once we drag this in and they kind of overlap, that's where the particles will spawn. So for instance, say if you have a plane or something going through a tree line or a building or something like that, or you have a tank crushing a car or something like that, and you want particles to spawn when that mesh overlaps, this is one way to do it. And so it's pretty cool to be able to use masking shapes and kind of tweak things. It's particularly great if I go to an example here. Where's it at? Ground fire. We use masking shapes to give us randomized particle positions. And so for instance, if I hide my simulation and I render my particles, you can see that this is where my particles are spawning, and you can kind of see what they're doing. So it's pretty cool to see. And then this right here is what influences where the fire is spawning. And you can see here that we've got this randomized noise shape, and this is where our particles are going to spawn as this noise animates and things like that. So pretty cool. And this is a true reason of why you might want to use masking shapes. So in this case, this is, I believe, emitting inside the masking shape. You can also do outside the masking shape. So it's kind of the inverse of what the shape is. So for instance, if we've got this whole cylinder here emitting, and then say we want to not emit where this sphere is, this is a good way to do that too. So also pretty interesting. So say you want to extinguish fire, or you want to make fire grow across an object or something like that. So you could come here and do that, which actually growing would probably be inside. So say you want to take this sphere and you want the fire to grow. Let's go ahead and turn off our particle rendering so that we just purely see the fire and how this would work. So you grow the emission shape, and then boom, now your fire is growing, and it's pretty cool. So that's kind of how the emission stuff works, and that's basically the basics of it. So this is how you get your particles into the world, and really quite cool. Very, very powerful. I believe you could probably even use masking shapes with like an animated vertex color on an object. And the way you would animate vertex color is, let's say we went to import, we go to mask, we would choose, say, our red channel, and then this reference value, you could animate that on the timeline down here by adding a couple of keys by shift clicking, and you could animate that to 1, and then the fire would grow across that object. But I think you could probably just do that directly by plugging in mask 1 into the shape. I don't have a vertex colored object on my computer right now, so I can't show it, but that is how you would do that. So pretty cool, and that's a way to get fire to spread across an object or something. Going back real quick to my original little demo here for showing off things. And so what I'm going to do is just create my active forces, turn it down to 0, so it's only what the particles are doing. And now we're going to go to the freeze tab. So for freezing particles, you can see that all of the particles are not doing anything once they spawn. And so we can do something called pause until unfreeze. And basically what that does is the particle's life isn't going to start counting down until they actually spawn. And so then we can see that we have an unfreeze simulation force. So if I turn this down to 0, the particles are immediately going to unfreeze. And so this is a cool thing that you can animate if you want to just make sure that all your particles unfreeze at a certain time. And then you've got your unfreeze min particles force. And so it's the force that's required by a separate node to make particles unfreeze. So there's two different things. So basically you've got one that's for your simulation. So basically if you want the simulation grid and it's influencing the particles, it needs to be a certain force. And you can see that we are influencing the particles. And so I would need active force on for some of those particles to start unfreezing. So let's go ahead and maximize that. And then we'll say, let's lower this until it starts to kind of decay. And so now you can see if we turn off our sim by pressing M, you can also go to view simulation, and that's how you can turn it off. But you can see that if we move this sphere into the simulation, that sphere is going to start to decay once the simulation reaches it. And so that's kind of a good way to unfreeze particles and things like that. So this is a good way to disintegrate an object. You can see that as we move the emitter, the particles spawn frozen until they are acted on by an outside force or whatever. And so pretty cool. And of course we can go here and we could increase the force. And so to do that, or we could decrease the level at which, say, a force noise takes to actually influence this. And so we could go down, and I believe we would need to go to active forces and bring this down to, say, 0. And I think the thing is we have to respawn the particles because they don't have that new active force on them. And so we can just do this, and this force is only plugged into the emitter once again. So there we go. So now all of them are unfreezing by default. And so there we go. So kind of interesting. And of course we can go here and go to our freeze, maximize our freeze, and this is already 10. So we'll do something like, say, 2 or whatever. And it's kind of going to create this dripping effect. And you can see the point light is right in between the particles. So really, really cool. So pretty awesome. So pretty cool. So that's how the freeze stuff works. And to go back again, just to show a couple of cool examples of what freezing can do for you. We've got kind of this pillar, frozen particles, and then we spawn a point force that kind of blows up the pillar here. And then I go ahead and unfreeze all particles by changing what it takes to unfreeze them. And so, boom, we've got a nice little collapse. And of course, the particles don't collide with each other. They only collide with the ground. So they don't stack up like grains would. But this is a pretty great way to fake, things like dissolving or collapses and things like that. So really, really quite cool. And it's awesome because you can just come in here, change the shape to anything you want. You can add in a new one. So say we added like a larger cylinder here or whatever. Really cool to just do that, and this system will work with pretty much anything, and it's easy to just come in and adjust this or whatever and create some cool shapes. You could have this be a mesh if you wanted it to be, and because this is really quite a faked way to do a dissolve, it's not connected with each thing, so you can kind of see why you would have to time your unfreeze or whatever to kind of make everything collapse at the right time, because at this point this should not be standing, so we would probably want to, say, unfreeze this at a different time. And so boom, we've got something like that, and now it's going to collapse realistically. And the cool thing is that all these particles are injecting velocity and all kinds of other things, and that's kind of pushing our smoke around, making it really dynamic and realistic. And once the particles unfreeze, they are actually generating the smoke. So for instance, if I went here to injection and we turned off injection, this is what it's going to look like. And so those particles are not going to unfreeze because they need the simulation's forces to unfreeze. So this is what happens with just the particle forces. And then we turn on our injection. We're in, once the particles fall, they're, making the other particles fall, etc., through forces, and you get a nice collapse effect. So pretty cool. Going back to my little setup here, which is pretty neat. we're going to go through particle life. And so just real quick, it's very simple. So let's just say we said 0. Your particles are going to live for 0.01 seconds. And so they're just going to do their thing. You can also make them live for up to 20 seconds, or if you want to, you can type in, say, 520 or whatever if you wanted that, and we can reset those bounds. But basically, your particles will live for a very long time if you want them to. And so, of course, it's kind of a min-max slider, and as always, you can drag the whole little bar around if you want to kind of randomize things. So basically it's saying, the least amount of life my particles could have is, say, 4 seconds, and the maximum amount of life my particles can have is 6 seconds, and after 6 seconds, no more particles will exist if you had, say, just a burst. So let's do a burst, and we will see we're at 1 second, going to be 2 seconds, 3 seconds, and by 6 seconds, all these particles are going to be gone. You can see them fading away, and boom. At 6 seconds, there's no more particles. So that's how life works. And then you've got timing randomness. I typically don't use this. I believe it has to do with emission. I would just ignore the parameter. It doesn't matter too much, but basically if you want, say, a burst to be separated between a couple frames, you want emission to be separated between a couple frames, this is kind of a way to do that. I don't know if it helps with like substeps or like lines in your particle emission if the sphere is moving fast or something like that. So it might help with something like that, but I don't know enough technical details. I never use it. So yeah. Initial forces is something really important too. So say we've got this burst, but we want it to really burst. So if we want to do that, we can do, say, a velocity range. And for this, because this is a force that is part of the particle system when it spawns, if your volume contribution is 100%, we know for a fact that initial forces are not going to work because it's following only 100% of the simulation's velocity field. So this is the simulation's velocity field. We can go to a 2D grid, let's say in the y-axis, maybe increase the maybe the arrow size here. And so we can see the simulation doing its magic, and those particles are going to follow this simulation. So you can see it being pushed by the pressure of the simulation, and now it's being pulled down, etc. So this is a great way to debug your simulations if you're like, I have no clue what the fuck is going on with my sim. You can come in here, visualize it as a 2D grid or whatever. You can change the slice position if you want to know what's really happening. You can also do a full 3D grid or whatever to see what's going on with your sim. But we can see for a fact that the particles are going to be affected by this simulation. So pretty cool, and it's a good way to debug things. But as we were saying, with the initial forces, we know that nothing is going to happen because it's being influenced by the volume. And so if we do, say, some of them influenced by the volume and some influenced completely by the particle forces themselves, some are going to drop, and there's kind of an in-between. Now let's do all of it being active with just the active forces. And so now we've got this initial force, and so let's see, without it, they just drop. But with it, they kind of expand outward. So we're basically saying, hey, I want your minimum speed to be -3, -3, and 8. So they're all going to kind of go upwards. We could do, say, -50 so that some of them shoot down or whatever. And it's kind of interesting. And so we could also say, hey, I want you to, say -3 in X, but let's do like +10 in Y or whatever. And so now these particles are going to shoot out, and then we could kind of keep the rest how it is. And then let's do emission, and let's say continuous. And so now we have a fountain of particles. If we make this a smaller radius, we kind of have this cool little fountain effect. And so you can see you can move this around, and the particles are respecting that velocity. Now, one thing to note is that this is respective of the orientation of your shape. So you can rotate this emitter around or whatever, and it's going to orient in the Y direction of that sphere or box or whatever it happens to be. So it is a localized force which is pretty cool. So that's really useful for things like flamethrowers or whatever. Quite cool. Now this initial force, I see somebody says, let's see, they said, is the injected volume of the particles also at once or affected with a force on volume only? Or does it take effect after the particle life? So if you're injecting stuff into the volume, it's over the entire particle's life. We'll go over that here in a bit. But basically, so you can see this is just an initial force. It only applies at the life of the particle, and then it stops. And then the rest of the stuff is going to take over, whether that's, dampening, so we can dampen the velocity. It's going to be gravity or whatever it happens to be taking over and being additive to the particle's force. So pretty interesting. So we'll go ahead and reset those parameters. The next thing we have is we have, say, velocity cone. And basically what this is going to say is I want to, and so Z1 means up, Y1 would mean in the Y direction, or whatever it happens to be. And we can reset our rotation to make sure that things are correct. And then basically we have a cone spread. And so let's go ahead and increase our velocity first off so that we can see what's happening here. So cone spread basically says I have a bunch of particles and I want to emit them in the shape of a cone. And so imagine an ice cream cone, being here. And so we can go ahead and let's say turn off our gravity completely so that we can just see how these particles emit with no other influence. So you can see here, we've got a cone of particles being emitted. This is really useful for things like directional explosions and things like that. And so, for instance, we've got kind of our emission speed limits, of course. We have something called ellipsoid distribution. In general, I don't really mess with this. I think it just kind of changes up how the particles emit just a little bit. I don't know if that means, let's see, is there any difference if I do 100%? Yes. So you can see that with ellipsoid distribution at 100%, it forms more of a spherical front or wave or whatever at the beginning. And then if we do 0, it's not as spherical. They're more kind of evenly spaced and whatnot. So that's what ellipsoid distribution does. And this is the cool thing about EmberGen. If you don't know what something does, you can either read the tooltip or you can read the speed scale, and it said something about entangled. So let's do an entangled emission here. And maybe we will increase our shape so we can kind of see all these crazy particles being emitted like sound waves is what that looks like. And so we can go to initial forces. And then if we do no ellipsoid distribution, you can kind of see that they're more spread out, more even versus direct sound wave looking things. So pretty interesting to see what that does. Of course, you have speed scale. So if you want your particles to go faster without changing your min or max speed, you can just do a multiple of it, and that's what speed scale does. And then you have velocity transfer. Basically what that means is if I move my emitter or my shape or whatever, I want to transfer the velocity of this to my particles. And so, of course, if this is, say, 0, and we move this around, it's not going to influence the particles at all as that shape moves around. That applies to imported characters or whatever it happens to be. So pretty cool. And then finally, we have localized force. The tooltip says the amount of randomization for the initial force of particles within a clump or entanglement string, 0% will give particle a random velocity, and 100% will give every particle within a clump or entangled string the same random velocity. So basically, particles are going to have the exact same velocity for each string. I think it will probably come through more with clumped. So if we do, say, clumped here, we can see, boom, the particles are all traveling at the same rate. Now, it is in a cone, so you can see that like they are spreading out, but all the particles within each clump are going the same speed. So that's what localized force does. You can use it. It's really cool if you want specific trails and things like that in an explosion. And we'll probably go through that a little bit later. But in general, this is kind of what things do. And then we also have inherent direction. I believe this only works if the particles or the object is moving. So say if I move this around, that's the only time the particles are going to spawn. And so it has to have velocity from an object, and the cones are going to inherit that direction. So this could be used for something, you know, particularly interesting, maybe like a sword swipe or something like that. You want the particles to follow that sword, and only when the sword is moving or whatever, this could be a pretty interesting way to do that. So that is basically initial forces. And so if we want to look at an example real quick of what initial forces can achieve for you, we've got this really cool explosion, and I'm going to bet if we go to our high velocity particles that we are using a cone, or actually in this case it is velocity from position. That makes sense. And so basically this is a good way to show velocity from position. So we have a speed limit of 15 to 300, and the offset is -16. And so if I have no offset at all, so let's say we do 5 or say 50, the particles are going to be pushed down. Let me turn off the spark stuff. Let me turn off the pressure wave. So we've just got these particles. They're going to aim down. And then we can say aim them up by doing -20. We could also aim them to the side by adding a position offset. So basically, we're going to say that the particles are spawning within the sphere. And if the center position is 0, they're going to spawn radially from this sphere. So it's going to be kind of evenly spaced or whatever, and they're going to have the min-max velocity. So this is a good way to have an explosive impact. And if we render our particles, you can kind of see what's happening here. We've got, you know, all these cool little entangled waves. So it looks like we are doing a localized force. If we had no localized force, you can see that they're just kind of all randomized, but the localized force really gives us some cool particle clumps. And then we've got just a normal speed scale. But we had this down by default to kind of give us more of like an artillery shell type explosion. And then we can go ahead and enable these other emitters, and let's hide our rendering. And then we can add in some pressure from this thing. And of course, this is a preset included with EmberGen. You can go in and dissect it if you need to. But this is just a great way to show how particles can add some really cool velocity to a simulation, add some streaks, add some trails, add in some cool spawning and things like that. And that's kind of where initial forces come in. It's great for burst, great for explosions, and other stuff. So we've also got this cannon explosion. And in this case, we've got two different particle systems. We've got one that is spawning all the smoke, and you can see here all the particle trails from the high velocity stuff. And then we've also got some sparks and embers. So we're rendering the emitters differently. So you can have multiple emitters if you want to, and they can all render differently. So this one is emissive and additive for the sparks. And then this one is probably, it actually is a rendering. That's probably for the light at the beginning. So you can see here, we've got a lot of light inside of the simulation. And actually, that might be from one of them. It might be from the other particles, or maybe a point light or something. I'm not sure how that's exactly working, but regardless, you could inject light if you want to, and we'll get into that here in just a bit. But regardless, one thing that I wanted to show, because this is a great way to visualize the difference between the volumetric active force, since it's probably the hardest thing to wrap your brain around. And so if we have volume contribution at 0, you can see that the particles just fly out. They don't get affected by the volume or anything. But if we maximize this to 100%, like it was, those embers and stuff are going to get pulled where that simulation is. They're going to rotate around, and they're going to, you know, get affected by the smoke and everything. And we can kind of see some here. They're kind of small, so maybe we increase the shape or something. It's going to be kind of ridiculous since sparks aren't really this big, but you can kind of see that they are, if I step through this, they are kind of getting pulled around in the smoke and whatever. But most of them are spawning in a really small position, so it's kind of interesting. Of course, we could increase our burst size to be completely ridiculous if we wanted to see a lot more particles, but really, really cool stuff about how particles work. So before we go into the other stuff, and I showed you velocity, position, and the other thing, but we can just do it in this little demo too, real quick, where if we go here, active forces, we can just say, let's just type it, 0, 0. You can see if we move the center position around, so we say something like negative y or negative x or negative z or whatever, it's going to kind of push those particles around and create an interesting force, pushing all the particles that way from the offset instead of a radial burst. And the last thing I'll say about the center or spawn from position is this is probably, if my money is right, velocity from position. And so this is a cool way to do something like a shock wave, where if you just want to emit things radially, this is a very easy way to do it. And you can do things that are pretty cool to instantly turn that into an artillery explosion, or kind of, throw those particles into the ground or whatever, or have, say, an offset shock wave. Say if you had like a Kami High or something like that from like Dragon Ball Z, you want particles to collide with the ground and push. This is a fantastic way to get some different results just by changing how your particles spawn. And by the way, particle spawning is everything whenever it comes to your simulation. I mean everything. So depending on how your particles spawn is going to determine what your simulation looks like. And so you really want to, try and finesse and think. So sometimes before I do a sim, which at this point, I just kind of know intuitively what's going to happen. But say if you don't know what's going to happen, you probably want to just play, maybe hide your simulation with M and just go through and spawn your particles and say, hey, like, is this particle system going to create the effect that I'm looking for? Is this particle system going to generate a shock wave? In this case, yes, I think this would probably generate a shock wave, especially if we're injecting velocity. And so we're going to go into injection here in a bit. But if I go back to my rendering, turn that off, and then show my simulation without velocity injection, we're just going to have a little explosion thing. And then, no velocity is following those particles. So velocity injection makes all the difference in the world as well. And it really helps push all those particles out. And if, once again, if we want to kind of come in and debug, and you're like, man, like what is happening with this simulation? We can come here. We can bring this Z-plane down to where the particles are. And we can see this shock wave actually propagating throughout the simulation. So this is what's happening as those particles are injecting velocity. So it's really cool to just come in and see, what's going on with your particles. So, don't forget that in the simulation node, you can come in and visualize stuff if you don't know how your particles are contributing to a simulation. So once you kind of get an intuition for this stuff, it's going to be easy breezy. So, yeah. So the next tab is active forces. And so we can just probably use this. So, we've gone over endlessly what it means to have active forces. So in this case, we've got these particles, and the particles are just going complete chaos. Because in this case, they're injecting velocity, and then as the velocity injects, that's going into the sim, and then the sim is saying, oh my gosh, I have to advect the particle even faster, or whatever, and then it's just kind of a really chaotic thing, and creates this really interesting emergent behavior because of that. And of course, you've got kind of a min-max between the two, so you can have it be some are full sim, some are full particle initial force, and then there's all the in between. You've got your gravity multiplier. So if we go back to my little dry ice thing here, and we want to say fully active forces only, if we say gravity multiplier is 0, nothing is going to happen. And so we can have some particles be affected by gravity, some not. And so this is kind of how you get a min-max for gravity, which is pretty useful. Say if you want some particles after an explosion or something to fall slower than others, this is where you would use that min-max slider for your gravity. So pretty cool. And so for instance, if we come here, we want to burst, make a little explosion, we would do, say, maybe velocity from position. Let's increase our speed scale to make it pretty explosive. Let's lower the amount of particles that are actually exploding, just so that we can kind of get a good idea here. And then maybe let's lower our center offset, so they kind of explode upwards. And so right now our gravity multiplier is 0 for some, so some are just going to travel indefinitely even out of the bounds. But we can say maybe let's do, some are like 50% gravity. And what that's going to do is it's going to, as we step through this sim, you can see that some are just falling slower than others. And so that's pretty cool, and it gives you a bit more dynamicism, more dynamic stuff within your particles, and just kind of adds to the realism or whatever. Then we have force tightness. Force tightness only applies to forces that are affecting the particles. So, one thing that's also very, very important to note is the difference between a volumetric force, the difference between a force that's affecting the volume and the particles, and a force that's affecting only the particles. So in this case, if we choose M, we can see that if we turn this noise force off, we have these nice little billows on the smoke. If we turn the noise force on, you can see that there's all kind of weird stuff happening with the simulation now, all kind of crazy turbulence and whatever. Now, this is affecting both the particles and the simulation. All right, and so I'm going to try and keep this coherent here. If we have the particles at 100% for both, we can see that this is still going to affect the particles. If I turn the thing to volume only, it's still going to affect the particles. If I turn it to particles, it's not going to affect the particles. And then you might say, hey, my force noise is broken. No, it's not. It's not broken because you're saying that my contribution to the volume is 100%. And I'm drilling this into your head because it's a very, very complicated concept to understand, at least at first. It took us forever to figure out how to simplify this. And then, of course, if we have somewhere in between, you've got kind of the whole in between. Some particles are following it and whatever. So it's pretty interesting. But now, because this is only affecting particles, you can see that if we make some particles fully follow the volume, some are just going to follow the volume and they're not going to be affected by that noise. So just kind of a cool way to give variation. Some are following the sim, some are following the active forces or whatever it happens to be, and whatnot. So pretty interesting. So I'm not going to cover too much more of the active forces, but that's kind of how things work. Gravity intensity, just what it says. It's kind of a multiplier on your gravity. You can do negative gravity if you want. You can do positive gravity, and things are going to fall to the floor. Then you have velocity dampening. So basically, if you want to slow your particles down, so let's say we have no gravity at all, and we make everything following all forces that are applied to the particles. We can say 100%, or actually 250% dampening. It's going to try its best to stop those particles. If I stop my force and I have just my initial force, those particles are going to come to a stop pretty quick. This could be useful, say if you want to just, what is it called? Kind of mimic, what do you call it? Like when something travels through the air and the air is slowing it down. So like friction in the air, there's a term for it. I guess dampening, air resistance. Yeah, so if you want to kind of mimic air resistance or something like that, that's what this is going to do. And if you pair it with gravity, those particles are going to slow down a lot faster, and they're not going to go as high if you had on velocity dampening. So that's kind of how things work. I'm going to hide my sim with M again, so that we only see the particles. And so finally, we're kind of coming down to collisions. You've got particle bounciness. So if this is 0, the particles are not going to bounce at all once they hit the bounds. Of course, this does apply to colliders as well. So particles can collide with a shape, and then they're just going to kind of slide down it or whatever it happens to be. So we've got no bounciness at all. And then we can do, say, some have no bouncy and all the way bouncy. So some are just going to slide, some are going to bounce. And then you can do 100% bouncy or whatever, and all of them are going to bounce at the same rate. We typically have something that's like 50 to 75%, so that they bounce at different heights and whatnot. Then you have particle friction, which is basically going to say, like, hey, I'm not going to let these particles slide much at all. And if we look at the thing, it says more friction equals stickier particles. So if you want your particles to slide around endlessly and things like that, you can kind of have low friction, but in general, friction is more realistic. And so you can see that they just went out with no friction. And let's do that again so that you can see. So the particles are going to kind of slide out. They're going to go out, maybe a bit more realistic to have something like, 7%, 12%, and they're going to behave a bit more like you would expect. So pretty cool. One other thing is bounce randomization. So basically, let's just do something kind of weird, and we're just going to say we're going to do one particle. Maybe let's do two, a few, whatever. I don't know why one particle didn't work, but regardless, we've got a few particles, and you can see that whenever they collide with this object, they're just going to keep going in the direction that they were already traveling, and it's just kind of an additional vector being applied to those particles and just saying, hey, like, I want you to kind of bounce and do your thing. But you might not always want to do that. You might want to say, hey, I want to add a little bit of randomization to your bounce. And so whenever you do that, they could completely reverse direction on you or whatever, and just completely randomize how those particles are colliding. And so you can see here, boom, completely randomized. Whereas if we go back and we say no bounce randomization, it's going to be very even in what you would expect. But you can add in some randomization to where, say, if they hit like a crack or a crevice or something like that, it's going to change the velocity of that particle. So this is one really cool way to get that done. Then you have repulsion distance, and that's basically how much are collider shapes actually going to push your particle. So it adds a velocity field around an object, and it's cool because I think you can even do like a negative repulsion distance, and it'll kind of suck in particles, but maybe you have to add some like active forces or something like that for the volume. Maybe. Yeah, it's kind of working, but that's also the smoke. So, and this is just me experimenting, so I didn't know what that would do if we had a negative force, but regardless, I think it applies whether it has volume contribution or not. So it's just kind of the force that's applied to it to make sure particles don't stick to it and things like that. Because if we remove this repulsion distance and say we just say 0, you can notice that those particles, at least in some cases like that, are kind of sliding down. Whereas if you have the repulsion distance, it's going to make sure that those particles get off of the sphere like you would hope. Then finally, you have different settings for how the particles are going to interact with your bounds. So for instance, you can say, hey, if you come over here and you collide with this side wall for the bounds, I want to make sure that you bounce. You can also say, guess what? If you leave the ground or you hit the ground, I want you to just immediately die. I want to kill those particles. I don't want them to spawn smoke anymore. I don't want them to do anything else. You can also say stop. So instead of bouncing or anything, they're just going to flat out stop. And then you have ignore. They're just going to pass through the bounds completely. And that's for both non-ground bounds and then the ground bounds. Because we realize that, say, for the ground, you might want to bounce, but for the side, you might want to be able to go outside of the bounds. So one thing to note about bounds while I'm on it is, let's say we do 32 by 32 by 32, which is the smallest simulation bounds we can have. Particles can be outside of them. They won't be lit, unfortunately. But say if we go to render real quick, we choose additive, and then maybe we make this like, I don't know, blue or something to make it kind of magical. And then maybe we want to make them emissive so that they glow. And so now we've got these cool little magic particles. You have an infinite bounding box to play with. And so, for instance, if we came here and we plugged in, say, a line force, and we added in a twist strength, these particles can twist for days and days and days outside of the bounds. You can also add in, say, some force noise to kind of break up, how that's working. And so we can do like a really high amplitude. So now you've got this really crazy swirly bit happening around the center, which is where the force line is. And so you can kind of move this thing outside of the bounds, and it's just going to affect everything. So this is a really, really cool way to do things out of the bounds and have much larger simulations. This gets particularly cool. I think this is a good time to show that there is something other than particle emitters that influence particles. So if you go to the simulation, there is a particles tab, and you have a particle max limit. So if we hit Shift S, we can see our particle count is about 18,000 here. So you can say up to 26 million particles in your pool. I believe that luckily you don't have to choose your particle pool anymore. It kind of scales dynamically up to this limit. And we also have something called high quality rendering. So basically it'll make sure that particles are never smaller than 1 pixel, no matter how far away you are. It does create quite the hit on performance, especially if you're kind of like far away or they're taking up a lot of the screen. So kind of be careful, especially if you're using a lot of particles. But it's really nice to know that you have that option should you want it. And then the most advanced thing here, and why I wanted to show you this, is we have something called grouping size. So this is another thing where you should pay attention. This is very important. Grouping size basically says, I want 16 particles at a time to clump together, or I want 256 particles at a time to clump together. And this is how you can create things like trails or larger chunks of debris to fly through a simulation. I'll show you the debris piece in a bit. But basically, we're saying, hey, I want 256 particles to follow a single parent. I'm choosing the grouping type of follow. We can do super sampling so that we have particles in between each other particles. So this is saying I'm going to spawn, 256 particles. They're all going to follow each other. And then between each of those 256 particles, 16 particles are going to spawn in between to make sure that we don't have any gaps like we do here. And you can do lower super sampling or whatever until it fits what you want. So you can kind of see we have these little lightning bolt like things traveling around. It's pretty cool. And then we've got trail color attenuation. So maybe you want those particles to fade out over the life of all those other particles. Then we also have something called trail inertia. So if these particles are kind of traveling around, do you want these particles to have inertia? Do you want them to kind of add in? So let's do something like, say, 500. You can really see, let's do like 5,000. Can we? 5,000? So you can kind of see that they've got this weird inertia effect going on. We can also do a negative inertia. So say like negative 5,000. And they're going to kind of do their thing. Let's remove all of our different forces. And so you can see you can get something pretty weird going on here as those particles travel. Or we could do something like this, and you get these weird hairs and stuff like that. So there's all kind of cool things you can do with particle trails. They look like you know what. Kind of funny. But anyway, so you've got these cool little things. You can do all kind of cool little hairs. So let's say we want to make this a little more advanced. We can go to emission. We can spawn just a crap load of them. And we can go here, since we have infinite bounds to work with, we can make a really large radius. And we've got some kind of magical thing. Let's choose a large line. And now we've got this cool little portal of trails or something like that. So pretty cool. And so that's all within the simulation particle node. And then finally, you can invert the trail ramp. And it does some other really weird things if you have inertia going on. But what it also does, as far as I know... Oh, it looks like it says... This should say trails inertia inverted ramp, because I thought it would invert the color attenuation, but it doesn't. So anyway, that's kind of how things work. The cool thing is you can have multiple forces on this. So say if we wanted a point force and we wanted to create an attraction force or something like that, we can do like negative 50, and that's going, or sorry, 50. That's going to repel particles, and we can do something like negative 50, and it's going to suck particles in wherever this thing is. And the cool thing is you can kind of move that around, and particles are going to do some pretty crazy stuff in a cool little trail thing. So really interesting what you can do with particles and trails and kind of how they work and create all kind of cool little effects. So many things to explore there. Going back into we did collisions. We've gone through that. So now let's focus on shape. So I'm going to just reload my little default thing that I've got set up here and set this down to, well, we don't really need to change what this is doing now. This will work fine for our shape. So we've got a display scale multiplier. So it's basically saying like, hey, like I want to have my particles spawn at between 0.9 or say 0.001. So really, really microscopic particles all the way to 0.1. And then I want to multiply against that scale to have different shaped particles. And you can see we've got all kind of randomly shaped particles. Really cool and neat and nifty and whatever. But one thing that's happening is the color over life, I believe, through rendering. Yeah, so we have like an alpha attenuation over life. Let's just go ahead and make that 0 so that particles kind of pop out of existence just for the sake of this demonstration. And we have something called a size by life modulation. You can come in here and just click a curve, or you can drag the little points, or you can create points or whatever. And so if you wanted to, you can come in here and create as many points as you want. And just by double clicking, and we're going to drag these things, and this will be particularly prominent if we add in a lot. And so now you can kind of see that the particles, if we focus on an individual one, say like right here, they're kind of like glowing. They're you know, increasing in shape, they're lowering in shape or whatever. And it's really quite cool. If we increase our display modifier for the scale, you can kind of see that the particles are growing and oscillating and doing all kind of stuff, and it's really cool. If you didn't want to do this curve by hand, you could come here to our display scale modifier, expose this to the graph just for instance, and you could create an oscillator here, and these particles are going to oscillate on their display scale, and we can increase that frequency, and so now these particles are just kind of grow back and forth. You can change the amount if you want to. You can change the what is it called? Where's the base? So we can lower the base. So if we don't want them to do whatever, and you can choose like you know, random noise or whatever it happens to be. There's all kind of weird things you can do, and you can see that it's following this line here, this random noise. You can kind of change your base, and you can do so many things with oscillators. That could be an entire training series just on how oscillators work and what they can be used for. But pretty cool to kind of see how, you know, the display scale works. That's a pretty interesting thing to do. I've never done it before until now, but I just thought of it. So pretty cool. That's kind of how these size limits work. One of the next things we have, we'll pause this, and we have something called sharpness. And so it's basically, hey, you know, do you want, you know, really smooth gradients on your particles, or do you want just a really sharp, you know, thing here? It looks kind of like a bokeh effect for like a camera or something like that. Kind of interesting. But so you have sharpness, and then you also have something called roundness. And I believe you need sharpness to be pretty much 0 for it to take effect. But basically, it says, hey, you know, do you want to make all of these little things look like little tiny spheres instead? And so that's what roundness is. So instead of you know, running these as, you know, kind of transparent particles that, you know, kind of all blend together, do you want them to be like little BBs or something like that, little spheres? And that's kind of what that makes it look like. So pretty interesting. Other than that, you've got your sharpness, and then it doesn't really work with the roundness. So you've got that. And then finally, we have something called particle render type. This is also very important. You can do velocity aligned. So if you want your particles to be round when they're not really moving, they can do that. And then they will angle towards the velocity and stretch out as there's a higher velocity. So cool way to do sparks and things like that. This is a really cool effect. And you can also do like fixed size so that they're always a particular size once a velocity is applied. And you've kind of got like a velocity scale, so it looks like a bunch of feathers. You got a velocity limit, things like that. You also have a blur type. So say you have like symmetric, so we can do velocity aligned and then symmetric. And what that's doing is it's kind of creating this weird symmetrical effect, so it's blurred on both sides. You can also do asymmetric, so that at the beginning of it, it's full opacity, and then it shifts the gradient to fade out towards the end. So you've got like a bunch of little arrows or birds or whatever. And then finally, you've got reverse asymmetric, so that the gradient is facing towards the direction, and then the arrowhead piece is facing where it's coming from. So kind of interesting to kind of choose these different shaping modes. You've got like a velocity limit, and you can kind of play with it to get different effects. Those look kind of like bubbles. It's kind of funny. But anyway, that's more or less how this stuff works with your shaping. And so you can do all kind of cool stuff, make them so that they grow into the simulation. And one interesting note is if I go here and let's make this a very small sphere and something like this, and then we add in an initial force. Let's do like a from position or something like that, and let's do full on active forces or whatever. So we've got these things kind of falling down, and we do smoke injection. And let's make sure that we are injecting stuff. Make sure we see the sim. Let's hide the other emitter. So basically, smoke isn't going to be emitted when the shape is 0. So for instance, if I come here and let's go, and I believe we can select all of these points like so. We can right click and choose maybe linear as our mode that we want to interpolate between. And so no smoke is going to spawn until they actually have some shape. So this is kind of an interesting way to delay smoke spawning or something like that if you have an explosion. So maybe you don't want them to spawn until they fall down or whatever it happens to be. So controlling your size controls injection of smoke and things like that. So pretty interesting. So that's pretty much shape. Next, we're going to go into rendering. I'm just going to kind of reset my scene here to how we were. Rendering is going to be pretty quick. So basically, with rendering, you can choose whether or not you want to render particles. You can choose whether or not they're lit or emissive. If it's lit, it means that it's going to be lit by point lights and directional lights and things like that. So if I move this light around, you can see that the particles are going to kind of be volumetric in nature. Because they are volumetric in nature in that sense, they are receiving light from voxels. So if they go outside of the bounds, they're not going to be lit anymore. So if you have an infinite particle simulation and you say, hey, like for some reason my particles aren't being lit, well, it's because they have to be in the bounds. Unfortunately, that's a limitation, but that's just how it works. And then you have translucent additive, so they can be both translucent and bright at the same time. You have just additive, so they all kind of add together. And then you have full translucent, which means that they're going to accept light properly. You can also do emissive particles, which means they're not going to receive light or anything. And then you can have translucent additive, and then you can have translucent additive plus emissive, which is basically really good for something like a spark. So if you really want these things to glow, but you want them to be easily seen and things like that. So this is more, I guess, if you're thinking about blending modes, this is more akin to something like pre-multiplied alpha. So the particles aren't going to like blow out each other if they're full additive like this. You'll still kind of be able to see some of the individual shapes and stuff like that if you don't have too much density of particles. Then you kind of got an emissive boost and stuff like that. So kind of a cool way to get something in between lit and additive and whatnot. So kind of interesting. You can also choose whether or not they're going to cast shadows. That does apply to smoke. So you can see here these particles are influencing the smoke on the volume here. Even if we have translucent, and then you have particles occlusion, you can determine how much they're going to occlude that smoke. And then finally, if we have something like additive, and then you choose emissive, your settings kind of change, and you have like an emissive boost. This is really cool for injecting, scattering and stuff. So, for instance, if I hide my particles, you can see here that those particles are still affecting the smoke. And unfortunately, this is a bug in EmberGen right now. Right now, you have to render particles to inject scattering and smoke. And a really good example for this, which is quite awesome. If you want to inject scattering in your smoke and see what it looks like, in lieu of, say, Diablo 4, this is what it reminds me of, some kind of magic blood portal or something. We've got particles coming here, and if we go to rendering, they are injecting light. And for instance, if I grab this color wheel and I just kind of rotate this around, you can see it will inject all kinds of crazy colors into my smoke based on the color of those particles. And so this is kind of a good example to dive into the initial color of particles. This is going to go kind of deep, so bear with me. But there are so many cool things you can do with particles. It is insane. So, especially with colors. So, you can have random per particle. Now, one thing to note is that all of these other settings, other than uniform, will not work unless you have a gradient plugged into your initial color. So, we're going to go ahead and set up a gradient. And we're going to set up, say, blue on this side. And we're going to set up, I don't know, yellow on this side. And then we're going to choose constant as our mode, just so that we can kind of get a good thing in between. And so now, if I, let's say, go to injection, hide my injection so that we don't have any smoke or whatever, turn off that other emitter. And so now we've kind of got this, cool little wispy fireball thing, this magic orb or whatever. It's got some interesting effects, and it's kind of interesting because this has a little bit of maximum volume contribution. You can kind of see how this changes too. It's a pretty good indicator of accepting particle forces versus volume, somewhere in between or whatever. So pretty cool. So if we turn on injection, it's going to start injecting smoke. So we can turn our smoke to 0, and we can see that right now it is not accepting our initial color or whatever, because we just have uniform color. So it's just going to accept this color that's right here. It's kind of weird because it should maybe pick the first thing from the gradient, but it doesn't for whatever reason. But we can choose random per particle. And so now it's going to make each particle choose a random spot on this gradient, and then make each particle that color. And so if we do something like translucent, we can really see that. If we make it lit, we can kind of see what's happening. And we actually have a point light down here, which is making those red. And so it's kind of adding in the light color or whatever. But so we've got these crazy colored particles or whatever. YouTube compression is probably killing this because this is like YouTube's worst nightmare. But you can see that they are random colors indeed. You can also do something like particle per matching size. I never use that, and I don't really know how to explain it. I guess you can have like a certain size or whatever. I guess there probably used to be a different thing that would help you select that. But you also have particles matching lifetime. I also don't really know how this is determined. I'm guessing, actually, if I could think about it, it's probably saying, hey, particles that have a low lifetime are going to be, maybe blue. Particles that have a high lifetime are going to be yellow. So it does look like the yellow survives the longest. And so it's basically choosing from this gradient. And so we can make most of them, blue or yellow or whatever it happens to be, and kind of change that gradient. And it's kind of an interesting way to color your particles. So pretty cool. If we go to, say, position based, this is another cool way. So of course we've got our gradient here, and let's maybe do like white and orange or something to kind of, or like a red color or something to kind of change this up. And so if we change the position of our shape, it's going through a noise field that's choosing from that gradient. So pretty interesting. So you can randomize your particle colors based on position in the simulation, which is pretty cool. So if we had no active forces at all, you could just see that as these particles spawn, they spawn as the same color based on that noise. And then you can see we've got like a noise frequency, and we have like a noise speed, so you can animate the noise, and it just kind of changes the various shapes of where those particles are going to spawn and whatnot. So kind of interesting. And then you have cycle with time. So basically, saying like, hey, like I'm going to go from white to red, from white to red, or whatever. It's just kind of back and forth. And it looks like it's going to go red, white, red, white, red, white, whatever, and just cycle over and over and over. Then you have ping pong with time, which basically says I'm going to go back and forth. I'm going to go red, or orange over to white, and then I'm going to bounce back, go from white back and forth. And then finally you have velocity based. So the particle's color will change based on the velocity. So we're going to be red if we're mostly stationary. We're going to be white if we're moving around a lot. And so it's kind of a cool way to change your particle colors there. Now, I personally never really use colored smoke, but your colored smoke, as far as I know, I'm about to find out, will inherit the color of your particles. And so with colored smoke mode, of course, you can't have fire or whatever it happens to be. But now if we move this shape and we start emitting velocity, you can see that we have white smoke. If we stop it, it's red smoke. And then somewhere in between, you could have a gradient, say that's like RGB, kind of in between. And so the faster it moves, the more white it is or whatever. But I don't know. You'd probably have to go in and change maybe like some max speed or something like that to kind of get a cool gradient in between. So yeah, so you can kind of see it does have a gradient or whatever in between. Now it is a bug. I don't know why this is yellow. This is why I typically advise just not to use colored smoke at all, which by the way, as like a public service announcement, if you want colored smoke, you don't have to use colored smoke mode. You can go into your shading node and change the color to be whatever you want. So if I wanted red smoke for this, I could just change it to be red there, and then make sure that I'm injecting smoke. And yeah, I don't know why my injection isn't injecting smoke, but let's try and debug that for a second. Maybe make the smoke white. Particles, injection, emission. Oh, I have to press M to see my smoke, I think. Huh, I don't know. Why are you not injecting? Maybe, I don't know. Something happened and the particles aren't respecting it. Let's see, will you emit smoke if I do this? Sorry, I'm just debugging real quick. Fuel, add maximum smoke. Huh, looks like, oh, it's because I have a gradient on my smoke. That's why. And, it's kind of weird. I can't undo it. Okay, there we go. So now I've got a single color for my smoke. Yeah, so also PSA, if you can't see smoke sometimes or your fire, it's probably because a gradient got disconnected. All right, so we've got this red smoke here. So yeah, so if you want a colored smoke, the best way to do it is to just color it through this little color wheel. You can do a gradient, you can do an exposed color ramp, whatever you want, and it's being colored from like the emitter, emitting light and stuff like that too. But pretty interesting because you can just come in and add multiple colors or whatever you want. They're not going to blend. It's going to be based on the density, but overall it's more performant. You can actually have fire and all kind of stuff. So pretty interesting. Anyway, back on point. We've got all this crazy stuff with particles going on, and of course you can inject light. That's where we were. So we go here and let's see, rendering, emissive. And so, yeah, so you can use emissive boost and inject light or not. So pretty cool. So let's see. And of course, you know, all this cool smoke and stuff is coming from the particles because we are injecting smoke. And I think we're almost ready for that. The last thing I'm going to show with the actual rendering mode, which is also very important, is if we go here, we can do some custom modulation. So let's just say that, you know, we want to have, you know, maybe like a position-based, you know, initial color. We're going to come in and we're going to add in our gradient. And we just want it to be, you know, say from white to black. And so you can see the noise and how it kind of spawns different colored particles or whatever. Pretty cool. Maybe we can change the noise frequency if we want to, maybe lower it, give us some better results or whatever. Maybe we want the noise to be animated, whatever. So now the cool thing is say if we wanted to fade these things out with some kind of special modulator or whatever. So let's say we want to make the particles show up based on their speed, or we want to color them based on their speed. We can add in a gradient here for modulation color, and we can say, hey, the faster you go, the more bright I want you to be. The slower you go, the darker I want you to be. And one interesting thing is, say if this is additive mode, you can basically make particles show up only when they're going fast. And so this is pretty neat. And so we can kind of come here and only spawn particles or render the particles where there's a high enough velocity. Now the cool thing is that this modulation color is a kind of a multiplier on your particles. And so we could come here, we could say no initial color. Let's just make this fully white and just say uniform. And so now all the particles are going to spawn white. And then based on a gradient here, we could say, maybe we want a deeper yellow or whatever. And the faster the particles go, the more coloring they're going to have, so the redder they'll be. So this is kind of a cool way to also debug your simulation or something like that if you wanted to see where kind of the slow spots in the sim are or whatever by, kind of coming around and just say dragging this. This is a cool way to kind of visualize your velocity field in an interesting interactive way. So kind of cool. So either way, that's pretty much it with rendering. You can do it, over life. You can say, hey, as the particles fade out, I want them to be red, or I want them to fade to black or whatever. You have your modulation life limits. It's kind of hard to describe this. You just kind of have to play with it. I want better visualizers one day that kind of show off what those things do. You can also flip your gradient really easily. So if you want your particles to say fade to black and reverse this gradient, you can just flip it so that you don't have to do it. So you can see here that the faster they get, they're actually going to fade out, fade away based on this. The faster they go, and they'll be red at the beginning. So you can flip your gradient really easily. And then finally, you can attenuate it over life so that, as they live longer or whatever, they can fade out. So pretty neat. And I think with translucent, you have an alpha attenuation over life. If you want those to fade out, you also have a color attenuation over life, and you have an opacity setting. So if you want your particles to be a very low opacity, you can do that. And so you can barely see them, or you can make them full opacity so that you can see them or whatever. Very interesting. Finally, we are in the coolest thing of all of particles and why they're so awesome. So we're going to build a couple of effects from scratch here for those of you that have stayed with me. It looks like 68 people. So thank you for staying with me this long. I know that this stream is kind of long, but there's just so much to go over with particles. This really is kind of the masterclass. So why don't we go to maybe say home. And so if you go to home, you can start from a couple of interesting defaults. Maybe let's start from the default smoke, and we're going to build a shockwave first, which is pretty interesting. So we're going to go ahead and delete our emitter volume. We do not care about it at all. We want to spawn from particles because we want this to be a really detailed thing. And so we can see here that whenever we spawn our particle system, more or less, we have a stream of particles that are happening. It looks kind of like cigarette smoke. This is happening because it doesn't have a shape. So you can choose any shape you want. You can choose, a box. You can choose a capsule. You can choose a torus. I find that toruses work the best for shockwaves because basically the center position, because what we're going to do is we're going to use an initial force. We're going to do from position. That position is going to be in the center of this torus, and it's going to push all these things away. And you can see that these little particles are kind of blowing in the wind or whatever, because I believe we have a force line. And so we can just turn that off. We also have a force noise. We can turn that off too. We might want it in the future, but that's kind of what's going on. Now you'll notice that the particles are rising. You haven't told it to do anything. The reason why they're rising is because by default, we are injecting stuff in, typically it's temperature. And the reason why we inject temperature by default, at least from what I can understand, is because if you want to inject fire and the temperature was 0 and you change fire to be on, you'd say, why don't I see any fire? The reason you don't see any fire is because there's no temperature. So you can kind of increase the temperature and voila, now there's fire. It's pretty low resolution because we have a fairly large grid, but they're spawning in a small place, but it just kind of is what it is. And somebody said, will this be rewatchable? Yes, it will. It'll be on the same link. You'll be able to rewatch or whatever. And hopefully I'll have like chapters or something like that where you can skip around and learn what you want to learn or don't understand. But anyway, we're going to turn off our flames. We're only going to have smoke. So we're going to say 100%. Then you can kind of see we have something similar to the modulator curve. And so you can come here and select, special curves or whatever. And this is basically saying that over the particle's life, I'm going to emit less and less smoke. I typically like to have something that's kind of exponential like this. And then we can come here and select kind of all of these little curves. And we can say something like smooth. And we can right click this. We can say smooth. We can also have a handle type and say, auto clamped or whatever. And that might help us out a little bit with having a smoother curve by default. So you can also like flip your curves and whatnot. So kind of interesting, but regardless, we can just kind of come in here and tweak this with our Bezier handles too if we want to. That's kind of an easier way to do it as well. So cool. We've got this cool little curve. We're gonna make sure that smoke kind of fades out through the life. Maybe we only want say 0.5 life, for all of it, and then boom, like once the particles die, the smoke is still going to be here. It's going to rise or whatever. Kind of cool. We're also going to turn our temperature to 0 since this is a shock wave. And so now we can just kind of see our particles doing their thing, but not a whole lot. So we need a lot more initial force. But before we do that, we need to go to our active forces, and we can kind of see that, the volume contribution is pretty high. So we probably want some to be 0, and we'll leave some in with the volume like the other preset that I showed you. And pretty neat. And so we go to initial forces. We've got our velocity from position, but not a whole lot is happening. It turns out that a maximum of 5 is pretty slow, so we can increase our speed scale. And so now we've got kind of a neat little burst here. If we look at our bounds, and let's say we hide our ground, hide our sim, our simulation, I believe, has a very large voxel size. So by default, it might be something like this. But for the smoke, I wanted it to seem really large. So I changed the voxel size to 0.5. We can change the voxel count to be maybe 92 at the top, and we'll make it, say, 384 by 384 by 92. It's going to be about 14 million voxels. And now we have a much larger space to work with. We could also have these particles live a little bit longer. So maybe we'll say some could go out to 2. And you can kind of see this is a fairly slow moving shockwave, not very indicative of that, but let's go ahead before we, kind of change up our speed and multiply things a bit better. And so what we can do is let's make sure that we're injecting velocity. And now this is really going to start looking like a shockwave. Now, one problem that we're running into here is that we kind of have this cascade effect from so much volume contribution. And so basically, as the volume suck those particles up, they're still emitting, they're still injecting velocity up here and whatever. And so this is kind of a cool rocket blast or whatever it happens to be. And remember how I told you that your spawn shape for your particles is everything. And what I mean by that, like it really is everything. So we can go back and we can say, hey, like what if I made this a sphere? Well, now it's just kind of blow out like an explosion, and it's not going to have that center cutout where the torus is. You could also have a box. You can make the box long on one axis to have a longer explosion. You can come in here. We could say, hey, I want a tube, and so now it's like a kind of a tubular explosion or whatever, a tube-shaped explosion, a hollow cylinder. We could change the height we could change the radius, and now you have something kind of crazy or whatever. And so your spawn shape really is kind of everything. If we want some crisper details in our smoke, we can go to shading, rendering, and then smoke sharpening. And the reason I chose this preset, the default, was because the smoke shading was already really, really nice. And so that's quite cool. And so all this, what do you call it? The shader settings are already tuned really nicely for smoke, I thought. And so that's why I chose this one. So we're going to go back to our torus. We're going to play around, and we're going to say, well, if it's an explosion shockwave, we really don't need a ton of emission. We just want a burst. So this is where our emission burst kind of comes in. And so we can kind of see this shockwave, propagating really far. That probably has to do with our life. So we probably only want like 0.2, maybe 0.3 as the min and max. And so now we can just kind of adjust this maximum until we get something that we want. Maybe we do like 0.8. Pretty big shockwave, pretty cool. There's not a whole lot of additional smoke. Maybe we can make the minimum life a lot smaller. And then we can take our initial forces. Maybe we can make some of them 0 so that we still have a lot of stuff happening in the center. And we can kind of reduce our speed scale if we want, and then kind of change the min max this way, kind of reduce our speed scale. Just kind of change and finesse this this shockwave. Now, one thing to note is that say if we had dust or something going on, like brown desert dust or something like that, we would probably have a different smoke color. So we can kind of come in here and choose maybe a brown color or something like that, and just kind of finesse this a little bit, kind of change it, and pick a different color. Maybe something like that. Some red dust looks pretty cool. We can also come in and change our light intensity if we want to. And one thing to note is that we are spawning 1,000,000 particles. We're spawning them as a regular emission style. But remember, we can do things like clumps to kind of break up these plumes. We can also do entangled to give us some pretty interesting results. And so you can see here, we're still rendering these particles. You can kind of see how they get stretched out. So maybe in the initial forces, we want to localize the force to kind of be a better burst or whatever, make it radial, like we might expect, like a pressure front. So we've got some pretty interesting things going on here. If we wanted to upscale this simulation, we can. So we can go here, choose upscaling, and that's going to give us some more detail on our sim. We'll upscale again, and of course we're still seeing our particles, but we don't need to. And so yeah, it's kind of interesting. In the shading, we can also increase, say, our smoke density if we want the smoke to be denser. And then remember, in the injection, we also have this curve. So we could just say, hey, we want you to inject smoke throughout the entirety of your life. Now you have some really, really thick, inky looking smoke. And this is because we have such a high density now in our density scale, but also because we don't have a whole lot of vorticity intensity. And so let's go ahead and not render these particles as well. It's kind of annoying to see. And then maybe reduce the life. We really don't need them to be live so long or whatever. And then maybe just increase that speed scale again. So we can just kind of see we're finessing this. And the upscaling looks a bit odd. I think that's something that's broken with particles right this second. That's why it looks so pixelated. That's something that we're going to fix here soon. So I'm going to turn my upscaling off. So now we've got, our vorticity. We've got all these weird little things happening. So if I was a betting man, I would say that we probably want to increase our torus radius since we are using a larger voxel size. Might want to kind of come in and finesse this particle lifetime again. And with that localized force, we've got some really interesting things happening with that. So maybe that was a bad idea to scale like this. And so yeah, it's just kind of cool to see how all this works. We can change our minor radius, and now we're getting something more like a shockwave with a larger major radius, more particles, and pretty cool. We might need some more bounds, so we can easily come in here, say 768, 8 and go ahead and apply that resolution. And another thing is we seem to be having some ground collision stuff going on. So we can go into our initial forces and just maybe bring the center offset down. And that's actually going to propel those particles up. So maybe we want to force those particles into the ground a little bit more to really create a shockwave. And then on our forces, we also probably could use a solid ground. We probably should have enabled that from the start. That's going to enable the smoke to travel a lot more. Looks like we also have kind of collisions enabled. So if we want to, we could just say maybe stop or something like that for the particles. So kind of interesting. And so you can go here, play with, how the particles are, bouncing, play with their lifetime, play with their speed, etc. And we're probably aiming down too much. So we'll just kind of do this and make them go outwards. So really cool shockwave. This is a super huge detailed shockwave, but really, really awesome. And we can just see, like, it just takes, some finessing back and forth and whatever. And I wasn't really super prepared on the idea of how I was going to do it, but pretty neat overall. Pretty neat. And then, of course, we do have a shockwave example, which is quite a bit cooler in my opinion, which is, I think I'm going to crash. I crashed. Hooray. I don't know why I crashed, but I did. Cool. Presets. Let's go ahead and go down. And there we go. And so this was the other shockwave that I had shown, and pretty cool. So quite interesting. You can go in, dissect this, change, see how the radius changes that shockwave effect and whatever. Pretty cool. So now let's say that we want to make an explosion or whatever. For this, I'm going to use, we could go in and utilize, say, something like this. But let's try and recreate this explosion right here from scratch, and we'll make a little aerial explosion with particles. So, or we could even do something like this with your Houdini style shading, and I'll kind of give you a little bit of a master class on that here too right now. So, we could go in, duplicate any of these for the shading, but I kind of want to show you more from scratch. So let's just do a default project. And then we're going to go ahead and delete this. I really, we could use this emitter volume as well. And so what we can do is we're going to change our simulation size on, say, maybe the y-axis. Let's do like 350. And let's do a voxel size of like 0.2 just to give us a little bit larger bounds to work with without changing the scale. And then we can come over here. We're going to move this shape in negative y. We can see here's positive y. We're going to move it in negative y. And then let's just add in a sphere. It's kind of our classic shape for an explosion. So we've got this fire going on. And in this case, let's, instead of using the easy, fast way of velocity from position, let's do velocity from a cone. So imagine that we have maybe an aircraft blowing up, like a fighter jet or something, blowing up, and we want a bunch of trails and stuff like that, like I showed. So we can do velocity from a cone. We're going to make the cone direction be positive y, which is pretty cool. And then we're going to change our speed scale quite a bit. And then we know that since this is an explosion, we don't need constant emission like a flamethrower or whatever. So we can just use a burst emission. Pretty awesome. And then we can go ahead, choose our lifetime limit, maybe do 1 so that we can have some particles that fall and things like that. Looks like we have a really high volume contribution to the forces. So we're just going to kind of bring this down and get our nice cone shockwave here or whatever. Looks like we should expand the bounds. So maybe we'll do 350 here as well. And now we've got a pretty neat explosion. Now, one of the things is with explosions, not everything is going to have a large velocity, especially if it's something like a plane blowing up in the sky or whatever. So what we can do is we can have some of the initial forces here at 0. So now we're going to kind of have something in between. And one thing to note, this is where particle grouping comes in for a larger explosion, is we have like some really fine particles. We're probably emitting by default 1 million. And so, but maybe we want to group these together to give us some bigger trails. This is where going into the particles tab, doing, let's say maybe 64. Maybe we can do even bigger. Let's do like 256 and then change our sphere scale. So now we've got these cool trails happening. We can change our sphere scale. You can also do something like sphere stretch. So we didn't go over this thing with the follow, but you can choose whether or not you want your spheres to stretch out. Maybe you do for a trail. And then you can choose how many particles are happening per little sphere. And you can kind of see them right here, these little spheres of particles. And so kind of interesting as a way to generate cool explosions. And maybe we want a lot more gravity than is happening. So we'll maximize our gravity, and it's quite cool. And then we probably don't want them to hit the ground, so the lifetime is probably too much. So we'll do like 0.5. And I think that's a pretty cool thing. So now we're pretty much done with the particle emission. For the most part, we might come in and tweak it again or whatever. But to really get some detail in this explosion, let's go into our injection and see what's going on. Maybe let's maximize our smoke injection. Our temperature is probably fine. We could probably add in some fuel as well so that we get some extra burning happening. We don't have to. The cool thing about particles that's different from your normal emitter is you can actually inject flames directly. So here's just smoke. Here's with fuel being combusted and living for a while. And then here's just flames, and then all that stops once the particles die. So that's pretty cool. And we could say, let's just do full flames for the whole life of the particle or whatever instead. But then you kind of get this, popping out effect. And that's why you would typically have like a gradient or something to fade your flames over life or whatever it happens to be. So kind of interesting. You can do like an exponential gradient or something like that to kind of fade it out nicely. So now for more detail on this, let's go ahead. So we've got this minor turbulence, and it's on volume and particles. So that gives me an idea. Let's go ahead and choose force noise. We're going to do particles only. And then we're going to kind of crank up this amplitude. Let's just say type in 100 or something like that. And so that's going to give us some pretty crazy particle motion on top of our initial velocity. So now it's really looking like an explosion. We can kind of change the scale of that if we want to. And so those particles are just kind of, moving through this pretty crazy velocity field. Unfortunately, another bug is you have to have volume enabled to see your gradient here. We can go here and we can choose 2D grid and then maybe increase our density a bit. And you can kind of see with our arrow size, kind of this gradient. So these particles are going to be following this weird noise field or whatever. So kind of interesting. And so pretty chaotic as well. But now that it's applied to the volume, volume's going to go crazy. So that's why we just want to select just particles. We want them to go crazy, but not the volume. And we'll reduce that scale back down to give us some pretty cool motion on those particles. So that kind of gives us a pretty cool color at the beginning because we've got all the smoke emitting. And we've got that fire is going to come through. And next, we've got our, we'll just say just volume for this. We'll kind of increase our amplitude, kind of see what happens to the smoke and whatnot. Not a whole lot's going on. We can increase our octaves to give us a bit more detail on that. And so that's probably fine. And then we can go to our simulation, increase our vorticity to say something like 28 or whatever. That's going to give us a lot more cauliflower look and stuff like that, more detail on our smoke. Then we can go to shading and rendering. We can increase our smoke sharpening. We can also sharpen our flames and temperature if we want to, give us a bit more realistic look. And now we can go in and color our fire if we want to. But I told you that I was going to kind of give you a masterclass on the Houdini style shading. So what we can do is we're going to go to emissive masking, and we can kind of see these flames kind of, peeking through or whatever it happens to be. And by the way, I think that this sim is probably a bit too large. So we're going to reduce our radius here and maybe reduce the amount of particles so that we're not spawning as much. And just kind of go like that. And then for our cone, I didn't adjust the cone spreading. So maybe we do something a lot smaller, maybe like a what is that, 16-degree cone. And then finally maybe reduce our buoyancy or something like that to something like 10 so that it doesn't rise as much. And then we can also fade out smoke or whatever later, but pretty cool. So right now we're not really seeing any fire. And that's because once you get fire going on with your emissive masking, you can kind of change the width to get back, some of your scattering. But let's go ahead and crank up our shaping by flames to max. Then we want to do shaping by density as well. And we can kind of tone down our shaping by flames if we want, and kind of tone down that emissive mask. And so now you kind of have that Houdini style temperature-based, density-based stuff where the density is eroding that fire for you, and it's pretty cool. And so we can go ahead here, maybe pause this and kind of tweak it if we want. You can change like the frequency of it to kind of get more detail wherever you want. Change the masking intensity, and we probably want a bit more particles too in this case, since we want a lot of fire to happen. So pretty cool. And you can see that we've got our noise. One thing you can do with noise too is have like a mask shape. So we can add in actually the primitive where those particles spawn. And so that force noise is only going to apply inside the shape for those particles. And so it's kind of cool. So they'll go crazy inside the sphere, and then outside of the masking shape, they won't. So pretty interesting. Kind of a cool way to get some different shading. And of course, the rest of the color is just, from this gradient or whatever. You can come in and tweak it and, tweak it to your heart's desire or whatever. And so, and we can go here and kind of see what I've done. On the shading, we've got our emissive masking. Looks like I'm kind of animating the density reference a bit more advanced. You can also tweak like your histogram for your smoke or for your fire. You can increase the shaping by flames, things like that, and that's going to change the brightness. And pretty cool. And so it looks like here, I probably did particle grouping. I did, and then for the emitter, I only had 25,000. So you can have those coming down through gravity. I have a cylinder to kind of give me a better shape. And looks like on the lifetime it's 0.2, 0.4. I'm using velocity cone, very low volume contribution, and a very high gravity. So because sometimes, like we saw just whenever we were trying to make it, the gravity, even at 100, isn't strong enough sometimes. And if you have something large scale like an explosion and you really want particles to be drugged down, you can do like 500% on your gravity, and that'll be pretty cool. And we've got some really nice smoke coloring and stuff here. And then for the other fire type, I had a pretty interesting gradient here. And so if you want to use this gradient in others, you can just copy and paste it into another sim, or you can press the plus button and then that'll save that gradient to your palettes. So then if we go, say, into this one, we can go here and then choose that gradient. So you can also load and save gradients. You can share gradients with each other. So you can save it directly, and it'll save it as a EmberGen gradient file. So that's a good way to kind of pass them around. But really cool, and you kind of see what the difference is between the two gradients that we had originally. And then you can go much larger scale with your particles. So this is a much larger scale simulation. This is probably, let's see, 512 by 512 by 512. So really large sim, really nicely tuned fire. And then if we want something different, of course, we can come here and randomize these things. And then if we go and say maybe play around with randomizing some other things, like let's say our radius. So we can shift click and then go to the randomize tab. And let's do a random radius between, say, 20 and like 2. And so now we can come here and randomize and see what happens when we randomize our various sphere shapes and whatnot. So you can go through, randomize any parameter you want, and really quite cool. We could also randomize, maybe let's do it on a smaller thing real quick, just to show you how many variations you can get. Let's see. Let's randomize our burst size. So we'll shift click, randomize that. Let's also randomize maybe our initial force, or maybe like our cone spreading or something like that. So we'll randomize that, and then maybe randomize our speed scale. And so that'll give us some pretty interesting stuff. And then let's randomize our radius. So we go to the randomize tab. Looks like in particles, we've got our main seed, we've got our burst size. So let's say something between like 0 and 140,000. And then we'll do between 0 and 180 for the cone, and 0 and say like 2 for the speed scale. And then for our shape, let's do like between 0 and 24 or something. So now we're just going to get a bunch of random things. Looks like burst size is not randomizing correctly. So if somebody on the dev team could go through and check that, it doesn't look like it's randomizing the burst size properly. So where's my emission? Okay, I'll just keep the burst the same. And so you can kind of see that the difference between randomizing all those different parameters does all kind of weird stuff. But pretty cool. So you can kind of come in and tweak stuff, randomize things. It goes pretty crazy. And it's quite interesting. I haven't read much of the chat during the stream because I've been so focused on particles, but pretty much everything in EmberGen right now includes particles. You've kind of learned some of the important traits. So you've got your emission, you can freeze them, you've got your lifetime, you have the initial force on the particle, your active force on the particle, collisions, the shape at which they're going to render. So are they a little tiny sphere? Are they a little, dot? Do they have velocity with them? How are you going to render them? Are you going to color them? Are you going to inject light scattering? So say, for instance, here we've got some spark-like things, and we want to inject light into the smoke or whatever. We could totally have those injecting light if we wanted them to. And then, and also in the shading node under scattering, you have like a particle contribution somewhere. Yeah, particle contribution. So here you can make that say like 200%. And then those particles will actually start to contribute if we go here. Let's see, inject light. Yeah, so now they're going to contribute, light to the smoke or whatever. Going to be really bright. And those are kind of like little light sources. So pretty interesting. And also a cool trick, the way I get this cool velocity is we animate motion blur on the simulation. So pretty neat trick to do that. So kind of cool. You can also do cool things like bullet impacts with particles. That's quite awesome. We've done muzzle flashes with particles. I also showed one of my favorites, which is this ground fire. This is all through particles being emitted with fire. Quite awesome. Here's some of the muzzle flashes. And if we show and render these particles here, you can kind of see it's in the shape of a muzzle flash. So kind of like I said, shaping for your emitter is everything. So if you want a cool explosion, make the particles look like a cool explosion. If you want a muzzle flash, make the particles in the shape of a muzzle flash, and then spawn fire where those are. And that's going to give you something kind of like a muzzle flash. And you can come in, randomize the shape, get all kind of different muzzle flashes. Pretty cool. And then you've got something big like this. I've got this, oil fire. So we've got all these particles kind of, going around, colliding with the ground. And then boom, we've got this, Houdini-like shading going on with the emissive masking. Without it, we've got this. So we can turn off our shaping by density. We've got some pretty crazy fire. But if you do want that, crazy temperature-based type shading, you've got that. Turn on the emissive masking, and boom, it just magically works. So pretty cool. If anybody has any questions, let me know. I'm going to bring my camera back. This was a really fun stream. We lasted for about 2 hours. And yeah, any questions? I think I'm going to go ahead and pause this, call it a day, and let me just pull up my thing. Any thoughts? What did you guys think of this live training session? I am curious how you guys felt about it. I tried to be a bit more prepared and organized. Had a nice little presentation beforehand. Wanted to kind of up our production quality, so to speak, and make sure that we really hit everything. Give you a couple examples at the end. And yeah. So somebody says, say we have custom geometry that we need to sim to go through, like particle flows or trails along the inside of a twisting pipe, like smoke fire going through a custom exhaust pipe. You'll just have to wait for our custom collision stuff for that. Let me see if I can bring it up. Twitter, VASFIC. Maybe I can share my screen real quick. Let me go ahead and minimize my camera. And then once I find it, I will bring it in. Yeah. So we have new collision stuff that's going to be happening in EmberGen. We don't know what version number this is going to happen, but we'll have much more accurate collisions for this. And if we just kind of go down enough, I'm sure I can find more of the interesting colliders happening. So by the way, go give VASVIC a follow. It's VASSVIK if you want to see a lot of cool EmberGen stuff with sparse and everything else. I don't have to go too far, I don't think. This collision stuff wasn't terribly far away. It was really cool. Yeah, so here's some more collision stuff that's going to be happening. He had something that was similar to like a pipe system. Kind of. Yeah, so here you go. Imagine that these little circles are pipes. You've kind of got this where the smoke is colliding really, really well. So quite awesome. And you'll have much more realistic collisions. There's a lot of use cases that we still kind of have to develop for, so it's not going to be released just yet, but it is coming. So hopefully that'll help you, Ross Bros 3D. But for now, I would say that it's probably not too possible, just because collisions are really bad in EmberGen right this second. Adrian says that it's very valuable. Bam says it's an awesome guide. There's so much. There is. What scale simulation should I use? I imported a limbic with the object size of 1 meter. So the voxel size to 0.014. Yeah, don't do that. Don't set to 0.014. That is way too small. You want to use something like, what do you call it? Sorry, I got a phone call for a second. You probably want to use something like 0.1 as a minimum, and then like 0.2, 0.3, 0.4, etc. And that'll give you much better voxel sizes. These live streams are great. Thank you. So yeah, that's pretty much it. Get ready for our big stream on the 21st. Like I said, we're going to be going over showing LiquidGen live. We're going to be showing GeoGen live, which is our real-time terrain editor, LiquidGen being our liquid editor. We're going to be showing EmberGen 2.0's sparse stuff live, and hopefully we might have some cool demos for that. Show incredible voxel counts, and I'm going to have a really nicely set up, slides and presentation and stuff like that to kind of go through each of the products, kind of the stage that they're in, answer some questions, and it's going to be really quite exciting, I think. So, be prepared for that, and thanks for taking the time to sit here and watch this and go through particles. Now your next step is to go in and play with the particle systems, imagine things that you want to make, Make some shockwaves, make some explosions, make fire, use the particle injection to inject fire, smoke, temperature, etc. into the simulation, and just play around with it. Watching it is one thing, but doing it is another. And now you have a full resource that goes through every single parameter for particles to show you how they work and why they work. And once you kind of get the gist of like, hey, like if my particles go here and whatever, and I can create this base emission shape instead of just using a normal torus or a normal sphere with a volume emitter, I can get so many more cool things out of EmberGen. And you can render just the particles too for magic and lightning and all kind of weird stuff. So they're really, really quite awesome. Somebody said, will EmberGen 2.0 be open for beta testing as 1.0 was? Yes, whenever we're ready for beta testing, we will release it early for those of you who have licenses. And hopefully, if you don't have the suite, the stream in 2 weeks from now on the 21st will convince you to upgrade to the suite so that you can get LiquidGen, GeoGen, and any other tools we come out with whenever they are ready, because they are going to be seriously game-changing and awesome, and that money funds the development. So really cool. And I'll give more business side updates and stuff like that about the size of our team and the allocation of how we're allocating our developer resources and stuff like that. That's all going to be on the next stream. But anyway, not going to take up any more of your time. Thank you very much. Join our Discord, JangaFX.com/Discord, and happy to answer any questions there. I'll answer one more question. It says, currently the VDBs can get pretty massive in size. Are there any plans to implement any sort of compression a la Zebra VDB in the future? Probably not, because if you look at stuff like Zebra VDB or then I don't remember what it is, like neural VDB compression, they're all fairly bad. And what I say by that is it loses a lot of detail. There's some temporal instability, and the quality degradation is just massive. So it's pretty hard to compress a VDB effectively. It's just not good. And the whole point is that they want to compress it so that it can be in a game, but if it looks like shit, what's the point? Not to say anything bad about their compression stuff. It's lossless compression, and people have been doing that forever. So there's not a whole lot of point of it. So yeah, that's my view on it. Maybe our team has a different view, but that's my view on it. So yeah. Other than that, thank you for joining. We're going to go and exit the stream now, and thanks for joining. I hope you learned a lot, and I want you guys to be masters of the particle system. So good luck, and I wish you all the best. See you guys in 2 weeks on a huge stream. So be on the lookout. Lots of LiquidGen is going to be shown on that day. So it's finally coming. I'll talk to you guys later. See ya in the stream.